Today we're going to be multiplying rational expressions. So again, rational expressions is anything written as a fraction, and basically we're going to use our same fraction rules to multiply them. The thing about multiplying though, unless there's a monomial, you're really not going to multiply necessarily. So it's not going to look like multiplying exactly. But these are the steps that you're going to follow. You're going to factor each piece, just like you did with simplifying. Then you're going to state your restrictions. Again, just like you did with simplifying, you want to state your restrictions before you start canceling. Step number 3 is to cancel any common factors from top to bottom. And then step number 4 is if you have any monomials left in your problem, you multiply those together. However, any polynomials that you have left, you don't have to worry about foiling those back together. You could if you wanted to, but it's just a place to make a stupid mistake. So let's do an example. So this is what a multiplying rational expressions problem would look like. So again, step number 1, we need to factor all 4 pieces. So top left here, this is the difference of cubes. So that's where we take the cube root of both pieces, square the front term, change our sign, multiply those together, and then square the back term. And again, remember, this thing never factors. It looks very tempting, but it doesn't. Then we're going to go down here and factor this. This binomial down here has a GCF of 7x. So I would pull out a 7x, leaving me with x plus 2. Then over here in the numerator, this is a GCF of x squared, which when I pull that out would leave me with x squared minus 4. But that still factors again, so we want to go ahead and do that. So we want to make that x plus 2, x minus 2. Again, there was an in-between here, step here where we had an x squared minus 4 once we pulled this x squared out. Then we need to factor our last denominator. So 2 numbers that multiply to give me 8, subtract to give me 2, positive 4, and negative 2. And again, right now is where I want to write my restrictions. Your restrictions are in your denominator. So what would make this equal to 0? Well, that's if x is 0, so x cannot equal 0. What would make that 0? If x was negative 2. What would make this 0? If x was negative 4. And what would make this 0? If x was positive 2. So those are my restrictions. Then I go ahead and cancel anything that I can as long as I'm going top to bottom. So my x minus 2's cancel. My x plus 2's cancel. This is a polynomial, so I can't cancel part of it. This is a polynomial, so I can't cancel part of it. Same way here. However, these are monomials, so I can break those apart. So I'm free to cancel one of these 2 x's with this one down here. So that would become just an exponent of 1, and this x would be gone. So my final answer here, I have x minus 2, and then x squared plus 2x plus 4, all in the numerator. And then in the denominator, I have my 7, my x is gone, and my x plus 4. Double check to make sure I didn't miss any canceling. Again, if it just kills you, you can distribute that 7 in there if you want. You can distribute that x in there if you want. But just to leave it just like this is perfectly fine. And don't forget, again, your restrictions. Okay, so let's do one more example. So again, we have multiplying here. So step number 1 is factor each piece. Let's save this guy for last. We're going to go back to him in just a second. So let's do all the other ones first. Top right, that's a GCF. Pull out a 2. You're left with 2x plus 5. Bottom left, 2 numbers that multiply to give you 20, add to give you 9. That would be 5 and 4. So x plus 5 and x plus 4. This bottom left is the difference of squares. Perfect square in the front, perfect square in the back, minus sign in between. So that's 2x plus 5 and 2x minus 5. Now we've got to factor this guy. Again, if you've been using guess and check and that works for you, that's great. If it doesn't work for you, remember we multiply the 2 and the 15 together. That gives us a 30. So we're looking for two numbers that multiply to give us 30 and add to give us 13. That would be 10 and 3, but I don't put those in the parentheses. So then I come back over here, make my parentheses. Well, the only way I'm going to get 2x squared is 2x times x. So then 2 times what will give me either 10 or 3? 2 times a positive 5. And then 1 times what gives me 3? 1 times 3 gives me 3. Told you the factoring was going to keep coming back to haunt you. All right, so here we go. We need to do our restrictions here. So our restrictions, this one here on the left. Some of you are probably going, I have no idea how to do that. But remember, if you can't do it in your head, write it out, set it equal to 0, and solve for x. You all know how to solve that problem. Subtract 5, 2x equals negative 5, divide by 2, x equals negative 5 halves. So your first restriction here is x cannot equal negative 5 halves. Notice these two are the same except for the sign, so that's going to be a positive 5 halves. And these two are back to the easier ones, negative 5 and negative 4. So those are my restrictions. Now it's time to cancel. My 2x plus 5s cancel. My x plus 5s cancel. And that's all there is to it. Again, these are locked in because they're polynomials, so I can't just cross stuff out. So basically I'm left with 2x plus 3 over 2x minus 5 and x plus 4. Again, if it's killing you, you can distribute that too if you want, but that's just more work. And that's all there is to it. Make sure you're doing your quick checks so you can see how you're doing, because it always looks easy when the teacher does it.